Hey, guys! Welcome back to my channel. In today's video, we're going to talk about one of the most fascinating pieces of technology in the world, satellites. Do you ever wonder how these amazing machines orbit the Earth and provide us with essential services like GPS, television, and weather forecasting? Well, wonder no more because we are going to explore the science behind it all. I'll see you all next time. Video description. In this video, we will explore the science behind one of the most critical pieces of technology in our world, satellites. From the different types of orbits to the parts of a satellite and the science behind stable orbits, this video will take you on a journey to a whole new level of understanding. Get ready to learn something new and exciting. Shot 1. Introduction. Satellites have been an indispensable part of modern society for decades now, allowing us to communicate with friends and family around the world, stream our favorite shows, and even navigate ourselves while driving. But how do these complex machines operate? What keeps them up in the sky? Well, it all boils down to a few basic principles of physics, which we'll explore together. Visual. A stunning animation of the Earth with various satellites orbiting around it. Now, let's start with the basics. What is a satellite, exactly? A satellite is any object that orbits a planet or other celestial body within the gravity well of that body. In simpler terms, a satellite is any object that falls toward a planet but is also moving forward enough so that it never hits the surface. But how do they stay up there? That's where the concept of orbit comes in. Shot 2. Types of orbits. There are various types of orbits, each with their own advantages and disadvantages. Some orbits are designed for communication while others are meant for weather forecasting. Let's take a look at some common orbits. Visual. A diagram showing various orbits, such as geostationary, polar, and low Earth orbits. First up is a geostationary orbit. A satellite in this type of orbit is located at an altitude of around 22,000 miles above the Earth's equator and moves around the planet at the same speed as the Earth rotates on its axis. This makes it appear as though the satellite is hovering over a particular spot on the Earth's surface, thereby allowing it to provide continuous communication services. Next up is a polar orbit. These are orbits that take the satellite from pole to pole. Polar orbits are great for imaging the Earth's surface, making environmental observations, and mapping. But, since the Earth is rotating beneath the satellite, it's essential to time the satellite's orbit so that it will pass over the same location with the same lighting conditions. Finally, there are low Earth orbits, which are used by satellites that need to get up close and personal with the Earth's surface. These orbits are ideal for remote sensing applications, as well as weather forecasting and GPS. Shot 3. The science behind satellite orbits. Now that we know about various types of orbits, let's dive into the science that keeps satellites in orbit. Visual. Animation demonstrating how gravity and velocity keep satellites into orbit. The key to a stable orbit is balance between the speed of the satellite and the pull of the Earth's gravity. Gravity is the force that keeps the satellite in orbit, but it's not the same as weight. Weight is the amount of force that gravity pulls on an object, while gravity acts as a centripetal force to pull the satellite toward the Earth. Meanwhile, the satellite's high velocity creates enough inertia to balance the pull of gravity, keeping it circling the Earth indefinitely. Shot 4. Parts of a satellite. Okay, we've talked about how satellites stay up in space. Now let's talk about what's inside them. Visual. A diagram of a typical satellite with labels for its various parts. A satellite has two main parts, the payload and the bus. The payload is the equipment that performs the satellite's primary function, such as a camera, a communication antenna, or a weather sensor. The bus includes all other components of the satellite, like the power system, the propulsion system, and the attitude control system. To make sure that a satellite stays in orbit, it must be able to communicate with the Earth. For that, a satellite is equipped with one or more antennas that send and receive signals from the ground. But, since a satellite is so far away, it needs a lot of power to send and receive signals. So, it requires some sort of power source on board. The most common power sources are solar panels, which are used to convert sunlight into electricity. Shot 5. Conclusion. So, there you have it, guys. A quick rundown of how satellites work. From the different types of orbits to the science behind stable orbits, and the parts of a satellite, Now you know the basics of satellite technology. Visual. A rich montage of various satellites in orbit with some celestial music. I hope you enjoyed this video and learned something new today. If you did, don't forget to give it a thumbs up and subscribe to my channel for more juicy science content like this. As always, leave any questions or comments you have down below, and I'll see you all next time.